By factoring, you want to get one side of the equation equal to 0. So in number 1, we already have a 0 on one side of the equation. I know there's a lot of techniques out there that you may have been taught to factor. I don't care what method you use as long as you know how to factor. So let's take a look. What's the first thing, guys, you always look for first whenever you factor? You always check for what? Greatest. Remember, always check for a GCF first. That's the first thing you always want to check for, regardless of what technique of factoring that you're using. There is no GCF to pull out of x squared minus 3x minus 4, so what is this going to factor into? This is going to factor into what? X minus 4 and then x plus 1. And then remember, after you factor, you use your zero product property. You take each factor and set it equal to 0. So x minus 4 is equal to 0. X plus 1 is equal to 0. So x is going to be equal to 4 and negative 1. So any questions of how you can use factoring to solve a quadratic? Take a look at number 2. Remember, there is a GCF you can pull out of number 2. What's the greatest common factor you can pull out of number 2? 2. So I have 9x squared minus 1 is equal to 0. And then what is 9x squared minus 1 going to factor into? That's going to factor into a 3x plus 1 and a 3x minus 1. Difference of two perfect squares. So then remember, you can take your 3x plus 1, set it equal to 0. 3x minus 1 equals 0. Remember, the constant, unless you pull out a variable x, the constant's not going to be a part of your solution set. Had I yanked out an x, then I would have had to set the 2x equal to 0. So x is going to be equal to negative 1/3 and positive 1/3. So any questions on using factoring to solve those two equations? What are you going to have to do in number 3 before you can do your factoring? What do we need to get on the one side? We need to get a 0. So I'm going to add 6. So 5x squared minus 13x plus 6 is equal to 0. Some of you may use that x method. Some of you may use that m method. Some of you may use slide and divide. Like I said, I really don't care which method you use as long as you know how to solve it. Most of you use that x, I think, so you multiply 5 times 6, which is 30. And then you want to find the magical pair that's add together to give you negative 13. So that's going to give you a negative 10 and a negative 3. And then you rewrite that as 5x squared minus 10x. So go ahead and finish that for me, regardless of what method that you use. And you should have broken it down into x minus 2 times 5x minus 3. Again, if you need some extra practice factoring, you can come in during Girl Block or after school. I'll be more than happy to sit down and show you some different ways, and you can decide which way works best for you. So what are your solutions going to be? X is going to be equal to what? 3/5 and 2. So looking at number 4, again, what do you have to get on one side of the equation first before you can start factoring? You have to get a what? 0. So I'm going to add 12s to both sides. So 9s squared plus 12s plus 4 is equal to 0. Again, remember, make sure if you do have to manipulate to get that 0 on one side, make sure you get your terms in standard form. Start with the largest exponent and put them in decreasing form. Go ahead and finish number 4 for me. Put this into 3s plus 2 times 3s plus 2, or you can write it as 3s plus 2 to the second power. Any questions on number 4? So what are your solutions then going to be? S is going to be equal to what? Negative 2/3. Okay? So any questions on number 4? So number 5, you're going to have to manipulate and move over a couple terms. So I'm going to have to add y squared. Remember, you can only add y squared to another term that has a y squared in it. So 2y squared plus y squared is a 3y squared. Then I'm going to subtract y, and again, I can only subtract y from a term that has a y in it. So negative 4y minus y, be careful of your signs, that's going to be a negative 5y. Minus 8 is equal to 0. So any questions on where I got the 3y squared minus 5y minus 8 from? Okay, you guys go ahead and finish that for me. Oops. So then what are my solutions going to be? Y is equal to what? -1 and 8/3. Okay? So any questions, guys, on how you can use factoring to solve quadratics? So that's one way that you've learned to solve quadratics. Another way that you've learned to solve quadratics is you solve by isolating the square. So that's another way that you can solve quadratic equations. That's where you get the squared term all by itself and you do the square root of both sides of the equation. The thing you have to remember about this method, don't forget to take the plus or minus on both sides of the on that one side of the equation. So for example, in problem number 6, first thing you want to do is you want to get that x squared all by itself on one side of the equation. So I'm going to subtract 1, which will give me 2x squared equals 16. Then what am I going to do to get x squared by itself? Before I do square root, I got to get x squared by itself. Divide by 2. So x squared is equal to 8. Now that x squared is by itself, now what can I do to both sides of the equation? I can take the square root. So x is equal to, and again, don't forget your plus or minus. Can you simplify the square root of 8? The square root of 8 is going to simplify down to what? 2 square root 2. Remember, the plus or minus just stays in the front of the 2 square root 2. So take a look at number 7. What's going to be the first step to get x squared by itself? Add 12. So I have negative x squared is equal to negative 75. Am I ready to do the square root? No, because what do I have to do next? I have to divide by a -1 or multiply by a -1, so x squared is equal to 75. Now I'm going to take the what? Now I can take the square root. So x is equal to plus or minus. Don't forget that plus or minus. Can you simplify the square root of 75?
Yes.
Yes, it's going to go down to what? 5 square root of 3. So don't forget to simplify the radicals if you can. What's going to be the first step in number 8 to get that v squared by itself? Plus 1. So I have v squared over 12 is equal to 11 plus 1, which is 12. What's next? Multiply everything by 12. So v squared is equal to what? 144. Now I can take the square root, and what is the square root of 144? 12. And again, is it just 12? Plus or minus. So don't forget about that plus or minus. You also learned last year you can use this technique when you have a binomial, a set of parentheses, raised to the second power. So again, what you're going to do, again, you can want to isolate whatever is raised to the second power before you do the square root. So somehow, some way, I've got to get rid of the 2. Is it okay for me to distribute the 2 into the parentheses?
No.
No, because you're breaking order of operations. Remember, you have to take care of exponents before you multiply. However, what can you do to get rid of the 2? You can divide by 2. So I have x minus 3 squared is equal to 4. Now notice I have the parentheses to the second power all by itself, so I can take the square root. So I have x minus 3 is equal to plus or minus, and what is the square root of 4? 2. So now remember what you have here is you've got 2 equations to solve. You've got where x minus 3 is equal to positive 2. You have x minus 3 is equal to negative 2. So when there's no radical, if you take that square root and it's a perfect square and the radical goes away, you've got to break this up and write out the 2 separate equations. So what's x going to be equal to? X will be equal to 5 and 1. You guys go ahead and try number 10 on your own. What are you going to do to get rid of that 1/4? You're going to multiply by 4. So you guys go ahead and try. So this should be the answer that you come up with. Again, you have a radical left in your answer. It is okay to write it as 8 plus or minus 2 square root 7, but if you wrote it as 8 plus 2 square root 7 and 8 minus 2 square root 7, I'm absolutely okay with that. So either way you write the answer is fine. All right, like I said, you must break it out into 2 separate equations if the radical goes away. Any questions on number 10? Yeah, because you can't add them together because they're not like terms, because you don't have a square root of 7 with the 8. So you cannot add them together. Okay. Any other questions on number 10? So when you do number 11, I already have the parentheses squared by itself, so I'm already ready to go ahead and take the square root. So I have 2r minus 5 is equal to plus or minus 9. So again, in this case, remember you've got the radical gone, so you have to split this out into 2r minus 5 equals 9. 2r minus 5 equals negative 9. So when I add 5 to 9, that's going to give me 14. And when I divide by 2, r is equal to 7. Add 5 to negative 9, so 2r is equal to negative 4. Divide by 2, r is equal to negative 2. So any questions, guys, on another way that you can solve your quadratics by isolating the square by using the square root method? So that's another way that you guys have learned to solve quadratics. Of course, you've always got your good old quadratic formula. In case you forgot what the quadratic formula looks like, there it is. Just like factoring, before you can use the quadratic formula, you have to set one side equal to 0. Again, and when you're looking at a quadratic equation, you want the ax squared plus bx plus c equals 0. A is the number in front of x squared that you plug into the formula. B is the number in front of x that you'd plug into formula, and c is just your constant. So that's where the a, b, and c values come from. So like I said, just like with factoring, you need to have a 0 on one side of the equation, so I would have to subtract the 5. So 2x squared plus x minus 5 is equal to 0. So what is the a value going to be from this equation? A is equal to what? 2. What's b equal to? 1. And c is equal to negative 5. So then you plug your a, b's, and c's into the formula. So x is going to be equal to negative b, which is going to be negative 1, plus or minus the square root. B squared, so that's 1 squared, minus 4, times a, which is 2, times c, which is negative 5, all over 2 times a, or 2 times 2. So the trick with the quadratic formula is simplifying what's underneath the square root. So this is 1. Negative 4 times 2 is negative 8. Negative 8 times negative 5 is a positive 40. So 1 plus 40 is going to give me 41, all over 4. How do you know if you can simplify this? What's the first thing you actually need to do with this? You need to see if you can do what with that square root. See if you can simplify it. If you can't simplify the square root, you're done. You cannot simplify the fraction. Can you simplify the square root of 41? No. So this would be your final answer. Okay? So up till now, those are the 3 ways that you have to solve quadratics. So any questions on those? This is the new one, and we use completing the square, like I said, for a lot of other things besides just solving quadratics. And to be honest, I'll choose completing the square any day over quadratic formula because it's a lot simpler of an answer. You don't have a fraction, and you may have a radical to simplify, but you're not going to get the fraction and or the radical. So first of all, before we go over how to complete the square, what does x minus 8 to the second power mean? You're taking x minus 8 and you're multiplying it by itself. So remember, a common error some algebra students make is you just want to say that this is x squared minus 64 or x squared plus 64. You actually end up with a trinomial as your answer, x squared minus 16x plus 64. So never ever distribute that exponent into a set of parentheses when you see a plus or minus. Just like 2x plus 3. When you take 2x plus 3 and multiply by itself, I know when I FOIL, 2x times 2x gives me a 4x squared. Plus 6x plus 6x gives me a plus 12x. And 3 times 3 is a 9. We have a special name for these trinomials that we ended up with when we multiplied a binomial by itself. So that x squared minus 8x plus 16 is what's called a perfect square trinomial. And you've probably heard that word way back maybe in Algebra 1. A perfect square trinomial comes from taking a binomial and multiplying it by itself. And the reason why you call it a perfect square trinomial is because if you were to factor it, you would factor it as a binomial squared. So every perfect square trinomial can be factored as a binomial to the second power. And this is the idea that we use to help us solve quadratic equations by completing the square. So first of all, the first step is you always want to make sure the coefficient of x squared is a 1. If it isn't, you divide by the number. So unlike factoring or quadratic formula, you want to move the constant on the other side of the equation. So you only want x's on one side, constants on the other. You take half of the coefficient of x and you square it. So whatever number's in front of x, your b over 2, and you're going to square it. That's the formula for completing the square. And then you factor and solve. So let's take a look at an example on how we use completing the square. So here's my x squared plus 10x plus 24 equals 0. So my first step is you want to make sure that the number in front of x squared is a 1. And it is. So step 1 is complete. Step 2 is I want to put the constant on the other side. So I have to subtract 24 on both sides. So that's where I have the minus 24. So there's your second step. Now, what you're actually creating in step 3 is you're actually creating a perfect square trinomial. That's the purpose of this formula. The purpose of this formula is that on the left-hand side of this equation, you want to figure out what number do I need to add here to create a perfect square trinomial. So the way you figure out this number is you take the number in front of x. In this particular case, it's a 10. And what you just need to remember about completing the square, it's 10 over 2, and you're going to square it. So what is 10 divided by 2? 10 divided by 2 is 5, and then 5 squared is 25. So I'm going to add 25 to both sides of my equation. Remember, you've got to keep your equation in balance. If I add 25 on the left, I'm going to add 25 on the right. So that takes care of step 3. Now, what you should be able to do is you should be able to factor x squared plus 10x plus 25. What does that factor into? That factors into what? X plus 5 times x plus 5. Or what's another way to write x plus 5 times x plus 5? X plus 5 squared. Equals. Add together the negative 24 plus 25. And what is negative 24 plus 25? 1. Now it goes back. You should be able to solve this. Because now you go back to solving by taking the square root. So now you'll be able to take the square root of both sides. So I take the square root of both sides. I'm left with x plus 5 is equal to. What is the square root of 1? The square root of 1 is plus or minus 1. And then again, like we just practiced doing, you take x plus 5 equals 1. X plus 5 equals negative 1. So what are my solutions going to be? X is going to be equal to what? Negative 4 and negative 6. Had you tried to do quadratic formula, you would have had to simplify the radical and then simplify the fraction to get it down to the negative 4 and negative 6. All right, let's take a look at another one. So solve by completing the square. Factoring is not even an option here. So because you can't factor it. So this one, you'd have to use quadratic formula, but I will choose completing the square any day over quadratic formula. So again, my first step is I want to add the 1. You want to move the constant to the other side. So I have x squared plus 4x, and I always leave a blank after my x's, equals 1. And I put a blank there. The blank is the number that I need to figure out what I'm going to add to both sides of the equation. So by putting the blank on both sides, hopefully you don't forget to add the same number to both sides. So my third step is I've got to figure out the number I'm going to add here. So I take the number in front of x. I'm going to take 4. You always divide it by 2, and you square it. So what is 4 divided by 2? 2. And then what's 2 squared? 4. So I'm going to add 4 to the left. I'm going to add 4 to the right. After you add the 4, you should be able to factor this. What does x squared plus 4x plus 4 factor into? That factors into what? X plus 2 and x plus 2, or I can write it as x plus 2 to the second. Equals what? What's 1 plus 4? 5. So now what can you do to both sides of the equation to solve for x? You can take the what? Square root. So x plus 2 is equal to plus or minus square root 5. So finally, what's x going to equal? X will be equal to what? But you have to subtract the 2, so it's not going to be a positive 2, it's going to be a what? Negative 2. So it's negative 2 plus or minus square root 5. If you wrote it separately, if you wrote it as negative 2 plus square root 5, negative 2 minus square root 5, that's not incorrect. So think about, guys, had you had to do quadratic formula to solve this in the beginning, the quadratic formula would have given you a fraction and it would have given you that radical. You would have had to simplify quadratic formula all the way down to this negative 2 plus or minus square root 5. That's what I mean. Completing the square is going to give you a much simplified answer. Most of you can plug and chug in quadratic formula. That's not the issue. The issue is I see so many errors when it comes to simplifying the quadratic formula, whereas you don't have to worry about making those errors with completing the square. Like I said, we're going to use completing the square for other things besides just solving quadratics. You guys go ahead and try number 15 for me. In front of x, which is negative 5, I'm going to divide it by 2, and I'm going to square it. How do you square a fraction? You square what? Both the top and the bottom. So what is negative 5 to the second power? 25. And 2 squared is going to be 4. So I'm going to have to add 25 over 4 to both sides. I know you're not used to factoring with fractions, but you're not going to panic. Because if you look at the other 2 examples that I did, going back to the previous example, when I took 6 and I divided it by 2, that gave you a 3. And then when you squared it, you told me it was 9. When you factored it, notice that plus 3 was inside the parentheses. Look at the number you squared. It was a 3. That's not a coincidence. Look at the example before that. You took 4 and you divided it by 2, which is 2. And then you squared it. When you factored it, what number went inside the parentheses? It was a 2. It was the number you squared. That's not a coincidence. Go back to the very first example we did. When I took 10 and divided it by 2, it was a 5, and I squared the 5. Notice when I factored it, what number went inside the parentheses? It was the 5. So whatever number you squared, that's the number that turns out to be inside the parentheses when you factor it. So when I go to factor x squared minus 5x plus 24, that's going to be my x minus 5 over 2 to the second power. The number that I squared is what goes on the inside of the parentheses. Equals. Now, what is 1 plus 25 over 4? 29 over 4. So now get rid of the square. What are you going to do to both sides? You're going to take the square root. So x minus 5 over 2 equals plus or minus. Remember, when you have a fraction under a radical, which we were dealing with back in the first semester, remember you take the square root of the numerator, you divide it by the square root of the denominator. Can you simplify square root of 4?
Yes.
Yeah, that's going to give you a what? 2. Then what's your last and final step? Add 5 over 2. So x is equal to 5 over 2 plus or minus square root 29 over 2. You're always going to get the same denominator here because you're going to have a perfect square in that denominator. Can I write this as one big fraction? Yes. And that looks a lot like a number you would have had you done quadratic formula. I would take either answer. It doesn't matter if you write it as one big fraction or if you left them as two separate fractions. But this is what the answer would have looked like had you done quadratic formula. Okay? So any questions on completing the square? All right, so your homework today